Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios, and what I have for you today is the answer to a commenter on our recent video on test-driven development. And I'm gonna answer to this question, but also kind of expand a little bit the scope of the answer to something closer to things that confuse people who start with test-driven development. Because I think this question, while it looks very simple, it's a microcosm of things that people confuse or get confused by when they try to implement test-driven development for the first time, when they try to learn. So let's look at the question first, and then I'm gonna comment a little bit. We'll do a short example. And if you want a brief of what we're gonna talk about in this video, we will talk about the following confusions that people make. First of all, you need to be very careful what you are testing and what you are not supposed to test. We assume that the frameworks and the language and everything that you are using actually works fine because it has been tested by many other people. Now, of course, sometimes this assumption may be proven wrong, but that is a very rare event, and when it happens, we are dealing with something that's very different. But in general, we will assume that frameworks, libraries, programming languages, they work as advertised. If you don't trust the framework, library, and so on in a specific case, you can write tests for the framework, for the library, for that third party, for that specific case, and then prove it, send a bug report to the people who build it, and so on. So you can still use tests, but it won't be test-driven development. Second of all, what is the interesting behavior? And basically separating the happy path from the unhappy path. And third of all, you need to figure out what you are building, what is your contribution, right? What does your program do that is on top of the programming language, of the library, of the framework, okay? And I will admit that sometimes I'm a bit more paranoid and I will write extra tests for things that I know should be working in the programming language, but sometimes those extra tests are also meant for learning. Okay, so this is briefly what we'll talk about, but now let's go into the gist of it. The question comes from a comment from PVX215. Thank you so much for this question. It may look like a trivial question, but it's truly a microcosm of things that are worth to discuss. Okay. The question is, hi, I have a question. Suppose I have a problem where I want to add two positive numbers and produce a positive number. The approach to do this is, okay, so first of all, just a quick analysis. If we think on top of our mind, add two positive numbers, produce a positive number, which is the thing that is already implemented in the language and that we shouldn't worry too much about. Addition, right? So add is already something that is part of the programming language. What are the things that are not part of the programming language? Well, restricting to positive numbers or producing a positive number. And additional constraints here are, of course, another constraint is mathematics. Mathematically speaking, if you had two positive numbers, you should get a positive number. But depending on how arithmetic is implemented, this might not go so well. And we'll look into the happy path and the unhappy path in a moment. But first of all, this is the important part. Okay, separate what's in the language, what's in the framework, what's in the libraries, things that you trust are working because they've been tested by other people, from the things that you are adding on top. And the interesting behavior that we add on top is that this function should only allow positive numbers to come in. Now, how can you do that? You can do this through types, or you can do this through a number of other, through assertions, through exceptions, through throwing exceptions, through design by contract, as we discussed. So there are a number of ways of doing this, and we'll see what we can do. Okay. The approach to do this is, I'm going to skip a little bit on the approach and to the end of the question. The questions now, is this considered TDD? If no, what actions would make it TDD? Would using TDD for something such trivial be a waste of time compared to the approach I mentioned? Okay, so we have 3 different questions, and we need to examine. There's quite a lot to unpack here. So what's the approach that PVX215 proposes? Create a function with 2 inputs and 1 output. Assert input 1 is positive. Assert input 2 is positive. Assert output is positive. Assert output corresponds to addition of the 2 numbers. Test the function with a few corner cases to verify it works as expected. Keep inactive the tests. Enable them only if the function is modified again in the future. Okay. So first of all, I don't get from this question whether the assertion is part of the function. So assert input 1 is positive, input 2 is positive, output is positive. Output corresponds to addition of the 2 numbers. Is this part of the function, or is this part of a test? Because if it's part of a function, it's definitely not test-driven development. If it's part of a test, it's only test-driven development if you do it in cycles, right? So you write a test that fails, then you implement the code, and then refactor. Write another test, implement the code, refactor. This is what test-driven development is. It's just as simple as that. Now, looking at this approach, it might also correspond to design by contract. But in design by contract, we will not be asserting these things, because what we assert is not inputs and outputs, right? We assert things that should be, preconditions, postconditions, and invariants. So what would be a precondition for this? A precondition for this function would be, if it's just a function outside any context, you could say the precondition is that input 1 is positive, input 2 is positive. Okay? A postcondition could be the output is positive. We might also test in the postcondition that the output corresponds to the addition of the 2 numbers if we want to. What would be the invariant? Then nothing else changes. So basically, ideally, you'd capture the whole context of the program. If this function is part of a class, you would capture the full context of the object before and compare with the one after and see that it's is the same. However, even if you do this design by contract approach, you can still write the tests for it. So you can still do test-driven development on this whole thing, and we'll see how in a moment. Kind of unpack this a little bit. But what really breaks the idea of test-driven development is keep inactive the tests. Why would you keep the tests inactive? Why? The whole idea of test-driven development is to build a base of a set of tests that fully cover your code and that can prove at any moment that your code doesn't break. And so if those tests are written as they should be, they will be extremely fast. They will run in milliseconds. And so you can run thousands of them in seconds. And you don't care, right? Yes, if you have a very big project, maybe you separate, and I don't know, if you take all the unit tests and run them, and I'm not talking about tests that touch the database, that touch the external systems, okay? Just about the ones that run in memory, basically. If you take all the tests that run in memory, maybe they will get up to, I don't know, 10, 20 seconds, 30 seconds, maybe. Maybe there's a warm-up period. In Java, for example, there used to be a bit of a warm-up period, and it might take a while for the tests to run. In Python, maybe it could be slightly longer than milliseconds. All right. But in that case, what you do is basically you run the tests on your current module, because I hope you have modules and you can separate the tests based on module, and that's how you do it. So there is absolutely no reason to keep the tests inactive. You just keep running them. You run them all the time. In fact, whenever you make a change anywhere in the system, you run all the tests, including the test for this one. That would be the ideal situation. We only go away from the ideal situation when there's some tests that are slow or unreliable and so on. Yeah, and well, if you have unreliable tests, just make them reliable or quarantine them. But that's a whole different other story. So the whole idea with test-driven development is to build this. It's something, to give you a metaphor, this would be the immune system of your application. Whenever you go in, you make some changes that introduce bugs, the immune system will fight against it and say, oops, something is happening in this part of the code that I don't expect. And then you look and compare the two and say, okay, is this something that I want to happen? If so, then change the test. If it's something I don't want to happen, then change the code. It's as easy as that. Okay. So this thing, so first of all, never, ever keep the tests inactive. You keep the tests active. First point. Second point, the way you describe this is not really test-driven development. And let's look at what would make test-driven development, and then we'll go back to answering C. And by the way, there's a follow-up to this question with a chat to ChatGPT about this problem, and maybe we'll look into it, unless this video becomes very long. Okay, so what do we want to have? Add two positive numbers and expect a positive number as a result. Cool. Here's what I recommend and how we teach test-driven development in Mozaic Works. We start by giving up examples. Okay? And it can be any type of examples. So in this case, we only have one function, which would be add, let's say. Or if we want to be precise, add positive numbers. This would be a more precise name. Okay, what are some examples of inputs and expected outputs? So we have input, let's say first number, second number. There's actually a technical name for this, like header and something else, but I actually don't like that one. So you can, if you want to be more precise, you'd use the terms from mathematics for this. Okay, first number. What would be a number? Let's say 1, 2, expect 3. Okay, cool. That's a good enough result. Let's take another one. 999. Yeah, this won't work. And second number 1000. Okay, so these are the common ones. And I could probably go and give another one like 3 and 2 million gives me 2,000,003. I hope I wrote this. Yeah, that's okay. Cool. So these would be kind of the normal values. Okay, now let's think about the edge cases. 0, 0, 0. Is this okay? Is this what we want to do? And this depends on the context now. When we say positive number, do we mean including 0 or excluding 0? So this is actually a business decision. Okay, or maybe an analyst decision. Question is, do we include 0 in positive? Do we include 0? So it's already an interesting question. These are trivial cases because we expect plus to work correctly, okay? But this is the interesting case, one of them. So let's assume we include 0. All right. Now, another one. Max int and 1. This should give us an exception. Or should it give us something else? Same is 1 and max int. We need to have the same. What's going on here? And yes, my autocomplete isn't helping me a lot. Exception. And then I should have a clear exception here. The question is, do we allow the default exception from the programming language to go through? Do we return an actual value? Maybe we can return max int. It won't make sense, but you know. Do we return something like not a number? Do we throw another exception? An exception like exceeded range of numbers, or something like that. So custom. Here we should have the same exception because otherwise it won't make sense, right? Okay, what else can we do? And of course, if we are here, max int and any positive int should give me an exception, right? It's not only with 1. But max int with 0 should give me max int, just to clarify. Okay, so we already have some interesting cases. Let's just separate those because those are different categories. What else? Well, if we try to pass in negative number, -1 and 1, what happens here? We have a few options, right? Exception. Or depending on the programming language, you may be able to restrict this through a type. Okay. If you are doing something like Haskell, or I think nowadays even in C++ you can do that. So you need to make some decisions. Okay, so if we look at this, the interesting cases are not this one, because I would expect these ones to work, but this is the happy path. So if I were to write tests, what I would do is I would start with the happy path, and the happy path would be these ones. But what this analysis shows is what we were discussing before, that you need to pay a lot of attention and just mentally separate the things that are in your programming language and that you expect them to work from the things that are not in your programming language. What would be other interesting situations? Well, depending on the programming language, what else can you do? Can you have a not a number and a 0? And what happens here? In some programming languages, not a number is an actual value that is not necessarily valid for int. So if you try to add using plus, you'll probably get an exception or sometimes an error, but you need to check your programming language to see how it works. But maybe in your case, it's okay if not a number plus 0, it's not a number. Okay, so in this case, do you return not a number? Do you return exception? And if you return exception, is it okay to have it as the normal exception, or that the language throws by default, or do you want to have a different exception? And not a number 1, in this case, we definitely, or maybe it's okay to have a not a number, depending on what you want, right? So basically not a number and any positive int. What do we want to have? A not a number or an exception? And these are decisions. Now, I'm laying this out just to show you what are the decisions that you make, and that the act of writing this method, while it looks like a very trivial function, may be indeed extremely trivial, because maybe you just care about this and everything else is custom. And everything else is default. Or maybe you just care about writing plus, return a plus b, that's all done. And in that case, okay. But maybe you also care about the different thing, the other things. And this is the type of analysis, you don't necessarily need to write this down like I did. But the act of writing these things down helps you figure out the steps in your test-driven development for beginners, for people who are starting. So it's not necessarily something that I advise you to do and that everybody should do when they do test-driven development. I think many people will not agree with this. But it's something that you can do when you are a beginner, just to figure out what it is that you are actually trying to accomplish. And this analysis will never be complete. Sometimes you'll find more cases. Sometimes you'll figure out and you'll remove some of these cases as you move along. It's fairly dynamic once you start the process of test driving. Okay. So now let's see how to do this. But before that, let me go back to what you said. Would using TDD for something such trivial be waste of time compared to the approach I mentioned? Okay. First of all, it's not as trivial as it looks, as you can see, right? Second of all, do you expect this method to change? Because if you expect this method to absolutely stay as it is, it might not be so interesting to have tests for it. And maybe it's tested through other things, right? Which, by the way, is a very common situation. You will probably use this function somewhere else, and you can test this function, its use cases, by testing other functions that call it for different reasons, solving an equation or computing formulas or whatever. So that might also be the case. But look, it's not as trivial. And once again, there's no harm in having the tests there. And there's no harm in figuring out these different situations. Okay. Now, let's go through step by step and try to implement this with test-driven development. And what I have here is a file where this is in Python. Let me just try to make this larger. First of all, as usual, I have a test that fails. And this just shows me that the infrastructure works. I'll probably upload this to a GitHub repository, so you can check that out. But the process is more interesting than the actual result, okay? Because the result will be most likely very trivial, or pretty trivial. Okay, so let's see. We have these examples. Well, let's try to use these examples. 1 plus 2 is 3. So test add assert add 1 and 2 equals 3. If I remember my Python correctly. Okay, name add is not defined. And actually I said, and by the way, this is the first design decision. Add positive numbers. Right? Is this how I called it? Add positive numbers. Yeah, this is a precise name. So already we made 1, 2, maybe 3 decisions about this function. first decision was the name of the function. Second decision was that it has 2 arguments. And yeah, that's basically it. And that it returns a value. Okay. I think I may need to create and to import something. So def add first, second, pass. Let's first see if this works, because I think I need to add positive numbers. Okay. Forgot about this already. Okay, and now that is not defined. Okay, so we need to from add import add positive numbers. Let's see if this works. Interrupted one error. I think I may need to create touch src init by just a moment. I have another project that I set up correctly, and init by src add. Okay. Let's see. Still no. One error during collection. Okay, let me just pause this for a moment and I'll be right back with the solution. And we are back. So yeah, I had to fix the imports, but now it's working. Okay, so what is it telling me now? What it's telling me is that test add assert none equals 3, which means it doesn't return what it's supposed to do. This is what we expected. So we wrote the function, we wrote the implementation, first plus second. Okay, make, okay, cool. And now normally what I would do is to commit this. Let's see if I can quickly make this happen. Let's ignore everything that is I think this is how you do it. Let's see a dry run. Okay, so first we need to add it ignore by force because we just ignore it. And I think, yeah, everything is pretty much what we want. Okay, adding works. Cool. Done that. All right. And now, so I did a commit. We are safe. Okay. If something goes bad, we can always go back. And that's how you do it. All right. Is it worth writing the other tests? I don't know. But first, let's look. Anything to refactor? And I would say yes, because I don't like the name of this method. First, it has to start with test. That's the convention of the library, although I don't like that either. But let's say add to so add two numbers returns the result. And look, if you want, you can use the Python convention with underscores. I don't really like that. These are style issues. Do whatever you like. Okay. Test still work. So commit rename test to clarify. Okay. So this worked. Now let's look into the next case. Do we want to do 999 plus 1? Maybe we want. Why not? I will do it here because it's basically the same test. So 901 by 1000. But these are already kind of paranoid tests. Okay. I don't expect them to fail, is what I'm trying to say. 3 plus 2 million. Okay. 3, 2 million is 2 million and 3. All right. And just for the sake of it, let's see if we do 2 million and 2 here. What happens? Add two numbers returns the result. The third, okay, it's telling me that is different. It's good. One thing I want to see is I want to see the output, because this shows me if the test will fail, what will I see? And I see tested two numbers returns the result. Assert 2 million 3 equals 2 million 2. Okay, I know precisely what the problem is. And that's good. Cool. Commit adding works with multiple examples. And look, if you really want to dive deeper into this, you can look into property-based testing. This is a good place for it. It's basically two numbers added between these limits will give us these values. That's fine. Okay, what would be the next one? So I said the next one is 0. Def test add number with 0 returns the number. Zero and 0 equals 0. I don't expect this to fail, but now this would be the first time when we make a decision, and the decision is we allow 0. Okay, 0 is a valuable, is a valid number. At positive numbers, 0 plus 100 equals 100. And just for the sake of it, let's do the other way around. 100 plus 0 equals 100. Okay. Why would I add this? Well, in case I need to validate numbers, the validation would be on the first input, on the second input. So one of them might fail and the other one not. And, well, I like to know about those things. Cool. Once again, let's see how this works if we Okay, a number with 0 returns the number, assert 100, 102. Cool. The failure message is fine. Let's commit. Allow adding to 0. Okay. Now, interesting part. Interesting part would be, no. What am I doing here? This. Maxint plus 1 and 1 plus maxint any positive int. Okay, not a number. But let's look at what happens when we try to add negative number with positive number. And let's for now just call it at positive numbers. Oh, sorry. Of -1, 1 equals 0, let's say. Okay, this passes, and this is not what we want. So the question is, what do we want? And I'm thinking maybe throw an exception. Right? So let's see how we can check for an exception. Okay, let's see. So we need to import PyTest, and then with PyTest raises exception as E. Right, I don't really remember how to do that. Oh, let's quickly check. With raises, oh, expected exception. Okay. So I would say how would you call this? It would be something like with PyTest. Okay. All right, so let's first write the test at positive numbers. Let's say we want, I think I would want a specific exception here. Negative not allowed. Maybe. Okay. Let's make. Name is not defined. Okay. We need to create of exception class is this did not raise class. Okay. Okay, so now what do we want to have? We want to add another line which says if first less 0 raise negative number not allowed of, okay, first number is negative. Okay, and we get one error. Yeah, sorry, this is my but I'm not sure I need the semicolons. Okay, cool. So we wrote a test that failed, and that said I'm expecting this exception. We ran it, we didn't get the exception. We then got the exception. Through the exception, the test passes. All right. Now this is one way of doing this. Of course, another way would be to just say, so let me quickly commit this. Check first parameter is positive. Cool. And this is what I was talking about when I'm talking about guard clauses. This is a guard clause. Now, another way we could do this is, instead of doing this, we could say assert first is greater than 0. And then this gives me an assertion error. If you want things like this, then what you would do is you would first write the test as I want an assertion error here. Test. Oh, okay, it actually fails because it throws the assertion error, I think. And the thing is, I don't really like this, as I was mentioning, because in the video about asserts, about debug asserts, the intent is not clear, okay? This is something that should be enabled in production. I should check for this value in production. Now, if I don't like, let's quickly, sorry. No, it raises every time. Forgot the if statement. Okay. So now what we have is something that is working in production. And if you really want to, you can implement your asserts around something like this. I mean, you could definitely have a validator object or something. Then maybe you inject using aspect-oriented programming before each method to check this. But it will still be part of the behavior of this function, so you still write the test for it, okay? Even if instead of writing this whole guard clause, you might have here something on the line of negative number not allowed of first, and a message, maybe. It's definitely something that you can do. It doesn't matter, however, how you implement it. Another option would be to just return a value and say, I'm returning 0, or I'm returning -1, or I'm returning something. But in that case, you would still test for that thing. So it's still a valid behavior because it's beyond what the programming language is doing. Okay? Okay. What we are missing here is the other way around, which is, let me quickly copy this. Test add positive number with negative number. positive numbers of 1 and -1. And the test fails because we are not raising. And now we have an option. We can either say first number is negative, second number is negative, or one of the arguments is negative. Normally, I would also check here the message, because the message is important. Well, depending on the context, right? Sometimes I would, sometimes I wouldn't. But in this case, I would definitely check the message because I think the message is important. So here, second less than 0, second number is negative. And maybe, well, if it's an exception and then you'll see negative number of allowances, yeah, I think the information is good enough. If this fails in the middle of another 1,000 tests, I can definitely figure out what's wrong. Okay. So with this being said, let's commit this. Check second parameter is positive. All right. And what other situations do we have? Well, we could write some more cases of add positive numbers with, first one is negative, second one is negative, and so on. Another thing we could do is to test for not a number, max int, and these are definitely valid things to test for. So my next test will probably be around max int. What happens there? Do we allow, I don't even know how Python does it. I don't know what's the maximum integer value. So I would have to search a little bit and see, okay, what's the maximum integer value? What happens when you add it to 1? Does it throw an exception and so on? And if it throws an exception, is it something that I can accept as an exception, or it's something that I don't like and maybe I will need to change? But I won't go there because I feel this video is already quite long. Yeah, it's almost an hour, so no time to get to the next step. But I hope you find this interesting. All right, so now let's go back to your question. Question A, is this considered TDD? No, as you describe it. What I showed you is what is TDD. Now, does it matter if you're using TDD or not? That depends. Okay. I'm not the one to say you must always use TDD or otherwise things will go bad. But TDD is an extremely useful tool, and my general argument is we need to understand deeply what TDD is and isn't before we make any rash decision about does it work or it doesn't work, or is it worth it or it's not worth it. Question B, what actions would make it TDD? I hope you saw how you can make it test-driven development. C, would using test-driven development for something such trivial be a waste of time compared to the approach that I mentioned? So I did this in less than an hour, but I also moved very slowly because I was explaining things. Normally, after you have the exercise and the practice under your belt, first of all, the initial analysis, the thing that I wrote in the markdown file, that happens almost every time automatically in your head. So you already figure out, okay, so Those are kind of the things that I need to test versus the things that I don't need to test because they are already in the framework programming language or library. Do I need to test plus? Not really. I only need a single test for that. So then what are the edge, what are the secondary interesting cases where when I'm passing negative values? But I'm going to start with a happy path, and then I'm going to go into first argument negative, second argument negative, and then I'm going to go into maybe not a number, have some conversations around, the exceptions that we are throwing, and so on. And if everything is clear, it probably takes you 15 minutes or so, right? That's what I would expect for this implementation. So, and what you get out of it is a set of tests that fixes the behavior to what you really want to happen. Now, is this helpful or not? You tell me. Okay. Think about your code. Think about where this code would be placed inside your application and how likely it is for it to not work as expected. Does it hurt? I don't think it hurts. So, and in general, one thing about test-driven development is that trivial is good. We try to take problems that are seemingly complex, split it into smaller problems, and then solve them one little step at a time. Because in this way, the chances to make a mistake are very low. And you are left with an immune system. The things that will check in case you or your colleagues or, it's Friday night, you are already over time, you are overworked, there's an incident, you need to fix it, and you make a mistake. Having the tests there, even for such trivial things, might save some hours of your time. And some people shouting at you. So, I don't know. While it's very unlikely that you'll make mistakes, the question is, have you thought about the other behaviors with not a number, with maximum values and so on? Are those the behaviors that you want? Because this is what this analysis brings to you. Now, of course, you could make this analysis and then write the code that fits all these cases without writing the tests. But then writing the tests is very trivial because every test is just 1 or 2 lines of code. It probably takes you a few minutes to do that. And it might save you in the long time. Even if, so here's one thing where it might save you. Let's say you have a bug and you realize that the bug can be in one of 5 places. And you have tests for 3 of those 5 places. It's already, you eliminate things immediately. Because if tests pass for those situations, it's unlikely that the bug is there. Well, you review the tests against the bug. And so you are left with the others. And, that might save you some time, even if this is trivial. Okay. So, would I recommend, if this was the only thing in your code, you can probably write it without test-driven development. But if this is part of a larger product, you are probably better off with writing it with test-driven development and leaving the tests active. Very important. Okay, we didn't have the time to go into your conversation with ChatGPT, but I hope this brings you some clarity. And I hope it's interesting for everyone else watching this video. And I hope you learned something new about test-driven development. But anyway, if you have questions, please let them in. Leave us a comment, because we love comments, as you can see. One of the perks of this channel is that one of your comments, one of your questions might turn into a video. So why not? It doesn't cost you anything. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.